This is Steve Wright for Imagineer Systems to tell you about planar tracking. It was innovated by Imagineer Systems in 2001, and its technology is applied to a variety of applications. Planar tracking is very different than point tracking or 3D camera tracking, and this video will show you why. In this first section, we're going to take a look at what is planar tracking. Planar tracking takes advantage of the fact that there are flat planes everywhere in our world. This wall, the floor, the three sides of this cube, they're all planes. There are even planes in the natural world. Planar tracking takes advantage of the knowledge that it's tracking a flat plane to assist in its computations of the tracking data. So let's take a look at how it works. We'll stop this, go to the first frame, turn on one of our splines, and we'll just draw a search area spline here. And you'll notice I'm not doing this with any great care, because I just wanted to find this front plane here to be tracked. Okay, so now I'm going to tell it to track the front plane. And you'll notice that I have drawn a search area like a point tracker, but the planar tracker grabs very large areas of texture, unlike the point tracker. You'll notice also that I drew well outside the edges here, because I wanted to give the planar tracker an idea where the boundary was. It actually uses the information of this moving data out here compared to the static plane there in order to help define the planar surface. Okay, we've finished the track. We'll move back to our frame 1, and now I'm going to turn on the planar surface. This is a little graphic that allows me to define the orientation of the plane. So I'm going to line it up with these four corners here. Now I can turn on the planar grid, and you can actually see the plane that it has tracked onto the planar surface of this cube. It actually creates a 2.5D plane that you can then attach rotosplines or four-corner pinning or any number of other applications. I have a little animation here for you that'll show you how the planar tracker works internally. Here's a test clip that we can demonstrate how the planar tracker works internally. What it does is it takes the area that you've defined with the spline, this search area here, and it makes a copy of it, and then every time the picture content moves, the planar tracker re-registers the search area on top of the new frame. It can follow a rotate, a scale, a perspective change, a skew, and it can do this because the planar tracker is grabbing very large areas of texture, not just a few little points here and there. This allows the planar tracker to track difficult targets that point trackers would normally fail on. It's much more immune to things like noise, motion blur, obstructions, and changes in lighting. I've reloaded the clip we had before with the planar grid on the front face of our cube. So the planar grid is now locked to the plane of the front face of that cube, and we can actually track multiple planes inside of one clip. For example, here's the side, and here's the top. This tracking data for any one of these planes can be exported in the form of stabilized data, match move data, or even corner pinning. But in the context of roto work, we can attach rotosplines to these planar grids, and they will move along with the planar tracking. Let's take a look at how that's done. We'll stop this, turn off the grid. I'm going to draw a spline right here on the top of my cube. So let's pretend that this is a rotospline. To lock this spline to the track of the top, all I have to do is select the spline, come down here and link it to the top track. Now this rotospline will now move with the top. Furthermore, I can turn on the rotospline's planar surface, and now I'm going to adjust it to make a little perspective thing here. Okay, we don't want to spend too much time on this. I'm just going to eyeball this approximately. Okay, now this planar surface, which is connected to this rotospline, is now connected to the top planar track. So now they will all move together in unison. I can now take and apply any kind of a graphic I want to that planar surface, like this logo, for example. And now the logo is locked to the planar surface that's tracked to the top of the box. This is how we attach rotosplines to planar surfaces when we're doing rotoscoping. While the planar tracker powers a variety of applications such as motion tracking, stabilizing, and four-corner pinning, when used in mocha to assist rotoscoping, it creates smoother, higher quality rotos faster with much less work because it does much of the work for you. In this section, we'll take a look at the impressive power of the planar tracker, how it can lock onto more difficult targets, produce more stable tracking data, and has greater resistance to obstructions than simple point trackers. We'll also get a good look at its great flexibility and how it can be used in many different ways. While this video is demonstration only, in the following tutorials we will get the step-by-step procedures on how to do all this. We'll start with a comparison of planar trackers to point trackers. We have a very difficult problem here in this shot. Let's say we need to get a track on the glasses on this character's face. As you can see, it has a number of challenges. There's transparency, reflections, grain, and changes in the aspect or viewing angle of the object. So let's start by seeing what a point tracker will do. I'm using Nuke, which has a world-class point tracker. So let's turn on our point tracker and see how well we do. So I'm going to move a tracker up here and tracker over there. We'll zoom in a little bit so we can watch the action up close. And I'm going to tell it to track. Oops! The point tracker errored out almost immediately. In fact, the tracker is never really locked on the target. Now that we saw the point tracker collapsed almost immediately, let's see how a planar tracker does. We'll zoom in a little bit so we can get a closer look. And we'll draw a tracking spline around the target. And now we'll track forward, see how we do. Now the planar tracker is grabbing much bigger bites of the picture than two little point trackers, so as you can see, it's able to stay on the goggles no problem at all. Truly an amazing demonstration. So we'll play that back and forth so we can see it at speed. Okay, we'll stop this. Now let's see how a 3D camera tracker does on the same problem. Using Nuke again, I've already done the camera track on this scene. So this is like using Buju or PF Track or Synthesize to track a scene to derive a 3D camera solve. We'll stop this, we'll look at the 3D view, and the camera tracker is going to give you a point cloud of the scene, and it's going to give you the camera solve, that is the camera's position and animation as well as the lens information. While this can be used to help with rotoscoping, it's really not the right tool. Now we'll take a look at several examples of the power of a planar tracker. One of the big challenges in tracking, of course, is targets moving out of frame. So let's take this shelf edge here, and because it moves out of frame, I'll play the clip for you. There you go. See it exiting the frame. What we're going to do is we're going to do a planar track on the edge of that shelf, and it'll be no problem keeping it even though it moves out of frame. So let's add our control points here. Okay, my tracking spline is ready. We'll track forward on this and see how we do. Because the planar tracking is looking at large areas of pixels, it's able to extrapolate where it's going out of frame. Okay, we're done. I'm going to reposition this so that we can watch it work. And you can see that the tracking spline stays locked to the target even though it's gone out of frame. We'll stop this. I'll hide this tracker and rehome the viewer so we can look at another case. The window. This is a very common problem. You want to track the window, but the content outside the window has a different parallax than the window frame and the windowsill itself. So how do we solve this problem? We do it by masking off the parts of the picture that are distracting the planar tracker. Like this. First, we'll scrub through the shot, looking for where we get our best take of the window. Let's say here at the end of the shot, I see the most window. I'll move this down a little bit. I'm going to draw my tracking spline. And again, no great care. Now, I'm going to turn on the mats. The planar tracker is actually searching the matte area that is being created by the spline. It's not searching the spline itself. So we'll go ahead and track this shot. I'll turn that off. I'm going to track this shot backwards, see how it does. To save time, we've edited out the tracking time. Okay, let's move the playhead back to where we started. I'm going to turn on the planar surface, line it up. This is a four-corner pin mark that tells Mocha where we want to put our graphics and all of that. All right, so you see it's nicely lined up with this part of the window here. But if I scrub back to the beginning of the shot, we can see that the planar surface has drifted off rather badly. So let's try to fix that. What we're going to do, first I'll turn off the planar surface, we're going to mask off the problem areas of the shot. So I'm going to draw another spline here. And now I'll adjust up the points a little bit. Now let's take a look at the mat. The new spline has created a holdout mat. The planar tracker will now not look at this part of the picture, and it will only look in the red part. But let's go a little bit further with this. We'll turn off the mats, get another spline, and let's clear this part of the window down here. Okay, and I'll just tweak these points a little bit. And now let's take a look at the search area. Okay, so this is a second holdout mat. You'll notice that the character is still covering part of the area we're tracking in this search area and this search area, but incredibly enough, the planar tracker will not be confused by that. Okay, we'll turn off the mats and we'll retrack our shot backwards. This same technique can be used to track a monitor. If there's a picture playing in the monitor, the planar tracker would be confused by all the moving picture. So you use the holdout mat to mask off the actual picture, while the outer roto spline gets the entire bezel of the monitor. And once again, we've edited out the tracking time so you don't have to watch that. So we'll move the playhead back to the end of the shot where we started the tracking. I'm going to turn off the splines so that we can see our planar surface now. So it starts perfectly lined up with the window. Now let's see how it holds over the length of the shot. There you go. So the planar surface is now locked to the window, and we can now do our compositing. I've deleted all splines and homed the viewer to show you how easily the planar tracker can cope with occluded targets, the bane of point trackers. In later tutorials, we will see how to set this all up, but for now, just want to show you what it can do. What we want to do is to track these boxes. Maybe we want to place a logo on the face of them. So let's see what the problem is. As I play the clip, you can see our character is moving in front of them, and the camera move is causing it to drift back and forth. So we have a real occluded target here. So let's see how we can deal with that. First of all, I've already created and tracked a shoulder spline, which will move with our character, like this. The idea is I'm going to use this spline to mask off my true tracking spline. I'll turn on the visibility for the spline that I've drawn around the box. This is the one that I'm going to use to track. Now if we look at the mats, we can see that what I've done is I've subtracted the shoulder mask from the box mask. And as I move the playhead, of course it's not tracked yet, but you can see how that shoulder mask is constantly erasing the one over the box. Remember that it is the red search area here that the planar tracker is using, not the splines themselves. All right, so let's track this backwards and see how it does. Okay, the tracking's done, so now let's play the clip, and you can see how the shoulder is masking off the boxes. So we should now have nice, clean tracking data for the box faces. We'll stop that in order to take a look at the planar surface. Before I turn that on, I'm going to turn off the mats, turn on the planar surface, and we can see in the zoom windows up in the corner, I've got this very carefully placed right there. Okay, put this planar surface down here, lower left, and we'll adjust the one in the lower right, like so. All right, I'm going to turn off the splines so that we can just watch the planar surface. We'll play the clip and see that it moves quite nicely with the box, even though the character covers it up. Now we can attach the mocha logo to the planar surface or one of the grids or even a moving clip. I'll turn off the planar surface. We can now see that the mocha logo now tracks very nicely with the boxes. In the comp, of course, we're going to need a mask to put the mocha logo behind the character. And we can use the shoulder track that we created for our character and export that as a mask, and even use that in the comp too. I've loaded a new clip to show you another very useful feature of planar tracking, which is how you can attach multiple rotosplines to one planar track. In the process, we'll also see another use for adding splines to the same layer. I'll turn on the two splines that I've already created and tracked. This one was drawn with the Create X-Spline Layer tool, which created the new layer. The second one was drawn with this, the Add X-Spline to Layer tool, which put it in the same layer as the first one. So as I turn that layer on and off, you can see that both splines are toggling on and off. I've already tracked them, so we have a very nice track, and now we're ready to actually use this. So this is another example of putting more than one spline in a layer. I'll move the playhead to a nice middle position so I get a good look at the wall, and I'm going to turn on the planar surface. And I'll adjust it real wide. Let me turn off the zoom windows. I'm going to adjust the planar surface to cover most of the wall, and I don't need to see the splines anymore, so I'll turn them off. Next, I'll turn on the planar grid. Now I can adjust the planar surface to line up the planar grid with my wall. Okay, so I'm going to adjust this so that the perspective matches the wall. All right, so there. Now, when I play the clip, the planar grid moves with the wall, and I now have a large planar surface that I can attach multiple rotosplines to. We'll stop that, turn off the grid, and turn off the planar surface. I can now go to any frame I want to add a spline. So I'll add a new layer, and I'll draw a spline around this brick here. Now as I move the playhead, you can see it's not attached to anything. I'll go back to where I was, and all I have to do is link this spline to the wall track. And now it's locked to the track. Okay, I'll go to another frame. Here's another brick I'd like to mask. Draw a new layer spline, and link him to the wall track. And now he's attached to my planar tracker. And I'll move the playhead down here and go get another brick over here. And attach him to the wall track. Now all three of these rotosplines are tracking together. I can turn on all the mats, and we can see that they track perfectly with each brick in the wall. This technique could be used to track one wall and then replace many different pictures in it, or even window panes in the same wall. We'll stop that. So there you have an overview of what planar tracking is all about. In the subsequent tutorials, we'll learn more how to set up, configure, and use planar tracking to export the tracking data to other programs, as well as for rotoscoping in Mocha.